Page 437 in your textbooks as we get started today. In your textbooks 437 for homework last night, you did numbers 6, 10, 12, 15, and 16. 6, 10, 12, 15, 16. Simplifying complex fractions. And remind me here, Brecken, what is a complex fraction? Good. In general, it's a fraction that has fractions in it. It might be a fraction over a fraction, which is often what we think of. It could be a whole number over a fraction. It could be a fraction over a whole number. But as long as there is a fraction somewhere within another fraction, we have a complex fraction. I told you it's important to remember that a complex fraction is simply a, Gavin? Well, that's by definition, yes. But for as far as how we work with them, we need to remember it's just a division problem, right? So we'd multiply by the reciprocal. Now the key is that it is, as Brecken said, a fraction singular over a fraction singular. And what we had in our homework in many instances was a couple of fractions or some polynomial expression in the top, polynomial expression in the bottom. So we got to get it all one fraction, then we can divide, or rather class multiply by the reciprocal. The other alternative, though, Noah, instead of getting a single fraction over a single fraction, would be to actually knock the fractional status out by multiplying everything by the LCD. And the reason that works in an equation, like we'll look at later, is because there's two sides of an equal sign. The reason that works in a complex fraction is because if what you do to the top, you do to the bottom, you haven't actually changed anything. You've multiplied by a 1. All right, so 6, 10, 12, 15, and 16. All right, let's go and take a look at these together. Number 6. Maddie, we'll start with you. We had a 4th plus 1x over, where are we? 3/5 minus x halves. And which way did you go with this? Multiply by the LCD, or did you get a single fraction over single fraction? All right, so in the numerator, you drew a fraction bar, and underneath it you put. And so here, top and bottom by. Here, top and bottom by. So what went above the fraction bar? Good. And then in the denominator, another fraction bar. Underneath that would go what, Noah?
That would be 10.
10. And so that means we're multiplying by
10.
To get a 10. To go from a 5 to 10, we're multiplying by 2. And here we'd be multiplying by 5. So what would go above the fraction bar?
6, -5.
And now we have one fraction over one fraction. Gavin, we're ready to multiply by the reciprocal. What do I write for my next step?
X, positive 4 over 4x times 5 over 6, -5.
Ooh, should have been a 10, right? Well, I think actually you may have originally had a 10 because I think I know what happened here. You went ahead to your next step, which was, once we set up our multiplication problem, factor and cancel, right? And we group or factor polynomials. They wouldn't factor, we just group them. And then we do cancel just a little bit. Brecken, what can cancel here? To get. So when we write our final answer, what do we end up getting back to Maddie? There we go. The only thing that canceled was a 2, which already can't equal 0. The only original denominator to our numerator is a 10. Well, that can't equal 0. So there we go. Could you distribute? Absolutely. If you had 5x plus 20 over 12 negative 10x, that would be fine. If you wanted to factor out a negative to reverse the order, is there a problem?
Change the x in the denominator.
Ah, thank you. I was just seeing if you were paying attention. Good. Okay. 2x times 6. She said 2x? She forgot the 2. All right, I was just writing what Maddie said. I'm going to shift the blame to her. That's what man has been doing since the beginning of time, is blame a woman. Okay, so blame, just kidding. All right, I should have caught it, though, to be fair, right? And again, I've said it before, those little monomials are sneaky and hide up there, so got to watch out, and Maddie and I didn't watch out, so good job, gentlemen, catching that. This should have been our answer, and again, as you could have distributed as well, though, why would you, right? Leave it that way. I also wouldn't factor out the negative, because even if I did, it's not going to cancel with anything, right? And I am lazy. Why would I do the work if it's not going to help me? And it wouldn't help me in that case. I'd leave it. How many have this answer here? All right, Maddie, other than the x, which I assume you had here and then just forgot, okay? Questions on number 6, I think was what that was. All right, let's take a look at the next one, which was number 10. And this one, I kind of like the other method because there's only one denominator the whole way through anyway, right? The only denominator in the entire problem class is, and when it's going to be that easy, I'm a big fan of multiplying everything by the LCD. Not the only way to work it for sure, but I wanted a chance to show this anyway. This is the perfect problem on which to do this. So I'm going to multiply everything by an x negative 3. You could say you're multiplying top and bottom by x negative 3, but if you show it this way, it just distributes it a little bit quicker for you. What would I get here, Noah, if I multiply everything by x negative 3?
2x negative 6 negative 4 over x negative 3.
Over who?
X negative 3.
Well, no, if I multiply everything by the x negative 3, that cancels. It's not over anything.
Oh. And then 6 negative 18.
6x negative 18? I'm not going to miss that x this time.
Negative 2.
There we go. So again, could you, by the way, if you'd gotten it over x negative 3, it would have been this over x negative 3 and this over x negative 3, right? And you would have multiplied by the reciprocal, and the x negative 3's would have canceled anyway, right? So this just is a little bit quicker way of knocking it out, especially when there's only one or maybe two easy denominators to work with. Do you want to combine just a little bit here, Gavin?
2x negative 10 and 6x negative 20.
And there is just a little bit we can do here to simplify our life, Brecken.
Go to 2 on the top. Give you x negative 5. Take out a 2 on the bottom. Give you 3x negative 10. And cancel the 2's.
And do we need to say 2 cannot equal 0, class? No, we don't need to specify that. But we did cancel away x negative 3's at the beginning, didn't we? So we do need to specify x cannot equal a positive 3. And again, just writing our answer a little bit more neatly now that we're done with everything else. X negative 5 over 3x negative 10. Should have had that answer regardless of how you solved it. How many did get that answer? Okay, a couple of you. Did anyone think to do it this way? You did attempt it this way then. Okay, question?
No, I was just saying, the way I did it, actually, I did the other way. It was quicker than that.
You feel like that was quicker? Okay, all right, maybe so then. I don't see how it could be other than, because you would have had this over x negative 3 and this over x negative 3, wouldn't you? Have you got the common denominator?
No.
I'm curious how what you did was quicker than that. Well, you did a lot mentally, which is fine. You're allowed to do a lot mentally. So you have less work on your paper, but you actually had more mental steps. So if you'd literally shown everything your brain was doing, like I'm doing here on the chalkboard, it would have taken a lot longer. No, I mean, certainly, yeah, you do more in your head, as long as you're accurate with it, and you were, which I have no problem with. I do most work in my head if I'm doing it for me. Yeah, it would probably be quicker. All right, let's go and move on to the next one, number 12. The 2 plus the 3 over x plus 1 and x minus 1. And a 5 minus 4 over x. Let's go ahead and do it the other way here. Let's go ahead and get the common denominator. I feel that's going to be the better route because the denominators, there's two different ones. They're a little bit more involved, not just monomials. So I'm going to go ahead and put these over 1. What goes under the long line here, Brecken? So here, obviously, got to multiply the x negative 1 to get. And then here, multiply by 1, technically. Really, we don't need to do anything, do we? We just write down. And then here, we need to put a long, oh, not really a long line. Underneath it, put x top bottom by to get here just leave it, put the -4. As we get ready to multiply by the reciprocal, let's simplify here just a little bit, Bracken.
2x over 1 and 5x over 1 and 5x negative 4 or x over
Good, because we're going to multiply by the reciprocal, so flipping that. Obviously, we would group and stuff like that. But is anything going to cancel at all, class? Anything going to factor? Or did we do anything? No. So what we might do here is make it all 1, but just slide the x out to the front. There is one excluded value we need. Anyone? Good. This x that was a denominator turned numerator can't be 0. And there's our answer. X times 2x plus 1 over x minus 1 times 5x negative 4, where x cannot equal 0. How many have that answer? To number 12, I believe this was. Okay, a couple of you questions. Just missed the excluded value. All right. Questions, comments at all on that? We feel like we're understanding it a little bit better today. You seem to be understanding it pretty well yesterday. How many would say, okay, after trying the homework, after seeing it, yes, it's seeming like a little bit more common sense here. Okay. All right, let's take a look at numero 15. 2 minus 1 over x positive 4. We've got a 3 minus 2 over x negative 5. And Noah, walk me through.
Put 2 in the 3 over 1.
Good, I like that for starters.
And then you put a long line. And then you put a shorter line on top. And you put x positive 4 underneath. And then on top you put 2x positive 7.
All right, so he went ahead and distributed in his head to get 2x positive 8, saw he was going to get a negative 1 to go along with that, and got the 2x plus 7. I've got no problem with that. That's what Gavin had been doing, a lot of this work in his head. No issue with that whatsoever. All right, down in the denominator, no?
You put 1 and then x negative 5 over 1. And then 3x negative 17.
Good, and again, here he did the distribution in his head, 3x negative 15. With another negative 2 gives you 3x negative 17. I believe most, if not all of you, capable of doing that in your head. I've got no issue with that. Is anything going to be able to factor or cancel at all here? Now, we can see pretty clearly. So let's just go straight to our answer. What would we have if we multiplied by the reciprocal?
2x plus 7 times x negative 5 over x positive 4 times 3x negative 17.
And do we see how we did the whole multiplication problem in our head? All right, there is one excluded value though, Noah.
X cannot equal 0.
X could equal 0. That's not actually probably
X cannot equal 5.
It can equal 5 because the x negative 5 had been in the denominator. And there's our answer. And so when you do a lot in your head, Gavin, this is how fast it can be. Again, on that previous problem I showed up, we could have done a lot in our head there as well. But I like that we went ahead and had a chance to show how we could do more in our head. Now, if you need to show these steps, fine, show them. You make sure you're accurate. I would say quizzes and tests, I'd recommend maybe showing the step. But on the homework as you're practicing, I've got no issue with that whatsoever. How many got the correct answer here on 15? All right, questions at all?
I just keep forgetting to combine what I have.
So the 8 and the negative 1 were two separate terms. Okay, so yeah, make sure we, coming over here, right, simplify. And then reducing hasn't happened a whole lot for us, but simplify first, and then if you can, reduce. All right, last one for homework was number 16. And we had 1 minus 1 over x negative 2 over a 4 positive 1 over x positive 3. Gavin, walk us through.
Make a long line.
Okay.
And on top, you put a smaller line. And then your small line, put x negative 2. And on top, put x negative 3.
Good, because here you're multiplying by an x negative 2 minus 1 is x negative 3.
And then on the bottom, put the next line and put x positive 3 on the bottom. And
Good, hopefully you follow what happened there. Any questions on how he got that so quickly? All right, so what is our answer? I think we're ready to just put it down.
X negative 3, x positive 3, over x negative 2, 4x positive 13.
You could say x squared negative 9. I wouldn't. I'd leave it in the factored form like Gavin did. One more thing to add.
And x cubed equals 30. Wait. Well, 3. Negative 30.
And there's our answer. How many have this answer for number 16? Okay, only Maddie. Okay, Noah as well found that answer. Okay, questions?
Just exclude value.
Excluded value again, all right. Questions at all? All right, why don't you take a look at number 17. It wasn't homework, but I want to look at it with you now. Number 17. This problem's a little bit different because as you look at the denominators in the problem, unlike all the denominators so far, you have one that could be factored. So as we copy it down, the numerator's fine. Just write down your 3 minus x over 5, or perhaps 3 over 1 minus x over 5. Then we've got a 1 over x negative 2, but the next fraction you write down, let's write it as 8 over, Maddie? Polynomial denominators, factor or group, just like we've been doing. Here for the first time, we get one that's actually factorable, one where it actually matters. I'm going to go and group that x negative 2 as well, just for good measure. But I think doing that one step will make this problem easier. Maddie, we're going to start, of course, with our long line here. We're going to put our long line in the top. We'll put our long line in the bottom, just like we've done on every problem. Maddie, walk me through the numerator here. All right, and what about in the denominator? All right, so Maddie, how would we write our answer? Where should we put this x? In the front. So let's start with the x, then the 15 negative x, then the x negative 2. All right. And one little thing that we wouldn't want to forget, Gavin, excluded values. What are the excluded values here? There's 2 of them.
0 or 2.
X is going to be 0 or 2, and there's our answer. So really, truly, not any more challenging in my estimation, at least. And maybe it's well, easy for you to say you're the math teacher. But I mean, would you not agree that just by factoring that, it made the whole problem still very straightforward? So complex fractions, we would agree, really aren't that bad. Okay? I want you to tackle number 18. Tackle number 18 now. Very similar problem to number 18. obliged to, Maggie. Excellent. What was it, Noah?
Parentheses and negative 1.
Right here?
Yeah, well, negative 1 exclude values and I just forgot the parentheses.
Ah, okay. All right. Gavin and Brecken, how'd we do? Brecken got it, Gavin got it. Excellent. So, so far, would we say fractions really not that bad? I mean, fractions tend to be one of those things in elementary, junior high, they're just absolutely terrifying. We've gotten to algebra now, we even throw letters and stuff in, and we say, actually, as long as I know how to factor, and here we didn't have to do a whole lot of even that, fractions really not too bad. So hopefully, by the way, this will deepen your understanding of regular fractions as well, because it's really kind of the same thing, just with factors we usually have to end up doing in our head. All right, one last concept we want to talk about before we get out of this fraction chapter, and we're done with it. Those are fun things to hear, right? We're going to revisit this idea of rational equations. We've talked about them before, so we're going to say rational equations part 2. Rational equations 2, this is the sequel. When a movie makes it big in the box office, they make a second one, right? Sequel, part 2. Now, rational equations, part 2, except it wasn't necessarily a huge hit at the box office the first time, but that doesn't stop us. Just like, well, anyway, Star Wars 7's no good. Let's make a Star Wars 8. It's got to be better. Star Wars 8's no good. Let's do a Star Wars 9. It's no good. They say they're going to stop. We'll see. Anyway, rational equations, part 2. First thing I want you to put down with these rational equations is to, you still want to clear the equation of fractions. You still want to clear the equation of fractions. That means multiply everything by the LCD. We still want to clear the equation of fractions, which means we still have to multiply everything by the LCD. So that has not changed. That's something in your notes from the first time, way back in chapter 2. When we talked about equations with fractions, or rational equations. So, taking you back for just a moment, if we had something like an x over 4 is equal to 11 minus 2x over 3. This is the type of equation we would have worked way back in chapter 2, back in, let's see, that would have been September, October-ish, right, that we would have done these. Well, we'd look at this and say, fractions. I hate fractions. You remember this? Yeah. All right, forever etched in your memory. And multiply everything by the LCD. So this is a thing, this is a thing, this is a thing. Everything gets multiplied by the LCD class, which is 12. And the idea, remember, is that the 12 and the 4 would cancel class to give us 1 and 3. Here the 12 has nothing to cancel with, right? There's a 1 down here. Here the 12 and 3 could cancel to give us 4, though we do it in reals. It's technically a negative 4, isn't it? And so what would the equation become then, Gavin?
3x equals 132.
132.
And negative 8x.
All right, and then of course we would look at this, and you didn't necessarily know to do all this back in the day, but we moved the negative 8x over class as a, to get 11x is equal to 132, and then works out easily to get x is equal class to 12. All right, and this is the kind of thing we would have done back in the day. The difference now is our denominators won't necessarily have to be numbers. They could involve variables. But still, write this down, if you have polynomial denominators, factor or group, if you have polynomial denominators, factor or group, you've got to do that because that's how you're going to tell what the LCD is. Just like it was necessary to adding fractions to have those factors visible, the same is going to be true in our equations. However, there's one more little detail. That means if there are variables in the denominator, follow me now, then that means the LCD is going to have variables, which means when I multiply everything by the LCD, I am going to be multiplying by variable or variables. Follow? What that will do, class, is it'll actually possibly add extra answers, because you're literally putting extra x's into the mix, right? And as you put extra x's into the mix, you're literally possibly creating answers that didn't used to exist. Follow? These are called extraneous roots. Write that term down if you would. Extraneous roots. These are answers which don't actually work, but you'll get them just by solving the way you're supposed to. You're doing what you're supposed to do. It's not that you made a mistake and got a wrong answer per se. You got an extra answer, an answer that doesn't satisfy the equation. So an extraneous root is an answer that doesn't work, but wasn't obtained via mistake. You didn't do anything wrong to get it. It just happens to not work out. And anytime you multiply by a variable, you've got to check all your answers to make sure that they're not extraneous. That's something I don't think we've had to do before. Have we gone over the term extraneous root this year? Okay, that is new for you then. I thought it was, but frankly, when you teach so many different maths, it's hard to keep up. So I try to remember which year is which. But yeah, so this is the first time you've seen this before. An extraneous root, again, is something that can be obtained not by making an error. It's just an extra answer that doesn't check. And as you go throughout math, especially next year in Algebra 2, you'll actually see a lot of different scenarios where extraneous roots could come around. And that's any time that you sort of, in a way, create an extra x. Anytime you multiply by some variable. So let's work several of these together. We have 1 over x plus 1 over 5 is equal to 3. This really isn't a whole lot different from what we did before, except that one of my denominators happens to have a variable. So when I multiply everything by the LCD, that LCD, of course, will involve a variable. What is my LCD, class?
5x.
5x. So I'm going to multiply everything by 5x. All right, let's go ahead and go from here. Just like before, we're going to look to cancel, and here the x's cancel, class, to give me 5. Here the 5's cancel to give me x. And here nothing cancels, I just get 15x. I need to get rid of the little x. Let's move the positive x over as a negative to get 5 is equal to 15x minus x? 14x. And then divide away the 14 to get x is equal to... It's just an ugly fraction.
14 over 5.
Other way around.
5
over 14. There we go. 5/14. And there's our answer. Now, how do you know how to check? Because frankly, I'm lazy. I don't want to check 5/14. I'm not really big into that. Well, the other way in which you could check it is simply make sure that in the original equation, this wasn't an excluded value. In the original equation, x could not equal 0, correct? Did we get that x was 0? Then it should be an answer that would satisfy. And if you did want to check, this one's actually not as bad as you might think. 1 over x always means reciprocal, right? So what is 1 over 5/14? 14/5. Right, just a reciprocal. Plus 1/5 is equal to 3. Well, 14/5 plus 1/5 is 15/5. Does that equal 3? Yeah, so it checks out. This is not an extraneous root. We're good on this one. But we want to check because we might get extraneous roots. I want you to write down this next equation. Do this one with me. X minus 4x is equal to 3. X minus 4x is equal to, let's make that a negative 3 if I can read my notes correctly. X minus 4x equals negative 3. Well, I see fraction. I hate fraction. I multiply everything, class, by x, the LCD. I'm going to multiply everything by x. What does my equation become here, Maddie? And notice, my equation has become a quadratic. Now going back in our minds, to solve a quadratic equation, start by setting the whole thing equal to 0. Let's move that 3x over, and when it moves over, class, it becomes positive. And remember, we want to put it in the middle so that we have descending order, right? And so now we're going to factor. So we set it equal to 0. We factor by way of reminder. X and x, signs class. Negative, positive. How does it split up the 4? 1 and 4, so that the 4 is the positive, so the outer inner gives us the positive 3x. Then we'll set each factor equal to 0, and we'll get 2 answers for x. What are our 2 answers for x? 1 and negative 4. Now again, looking at the original problem, x isn't allowed to be 0 per the original, right? Well, I didn't get that x was 0. Still wouldn't hurt to check. Let's plug in a 1. 1, right? And 4 divided by 1 is 4. So 1 minus 4 equals negative 3?
Yes.
Okay, this one checks. Let's try the negative 4. Obviously here that's just a negative 4. And what would negative 4 over negative 4 equal? Positive 1. Does that equal negative 3? Yeah. So neither of the roots happens to be extraneous, but you want to check. And this is one of the reasons we want to check is you literally turned what appeared to be single power into a second power by multiplying that x. You created a quadratic, and oftentimes when you create a quadratic, one of them won't check. Make sense? So that's why we want to make sure we're checking our roots. Questions on that one? Another one to write down. 2 over x negative 2. 2 over x negative 2 plus 2 over x plus 2 over x is equal to 4 over x squared negative 2x. 2 over x negative 2 plus 2 over x is equal to 4 over x squared negative 2x. I see polynomial denominators. What do I need to do here, Brecken? Or, right, now the x negative 2 isn't going to factor, right? So we'll just group that. X is a mononomial, don't worry about that. What about x squared negative 2x? To get x times. So, should be pretty obvious here. What's the LCD, Brecken? Right, x times x negative 2. Each of those things has a tie, so you just pick one of them. And so I'm going to multiply everything by x negative 2. When I do, what's going to cancel here, Brecken? So I just get 2x. What's going to cancel here? To get. And what's going to cancel here? So I just have 4. Questions on what we did so far? Everyone follow what Brecken did there. Now it's the easy part, right? Now we just solve. Brecken, let's combine like terms. And let's ditch the negative 4 to the other side as a positive to get. Ooh, careful. Ditch the other side as a positive to get 8. And we end up with x is equal to 2. Looking at the original equation, x negative 2 can't be 0. So we know that x class cannot equal 2. We also see that x is a denominator, so x also cannot be 0. Here, this x is already covered because x can't be 0. Here, x is already covered because x can't be 2. Thoughts on our answer? It's extraneous. X isn't allowed to be 2. If you try to check it, let's do that. 2 over, what's 2 minus 2? 0. You're not allowed to have a denominator 0, so we've got an undefined value plus, what's 2 over 2? 1 is equal to, let's see, 2 squared would be
4. Minus
minus 2 times 2 is
4.
4 minus 4 is 0. So we've got undefined value plus 1 equals undefined value. Number 1, you can't really define that, but no! Okay, so what do? My only answer is extraneous. No solution. It's a contradictory equation. Simply no solution. Nothing wrong with what I did. I solved it exactly right. Answer should have been x equals 2, but it's not allowed to be that, so I just don't get a solution. Questions on this? Questions on this extraneous root? Another one for you then. I'll write this one down if you would, please. X over x plus 3. X over x plus 3 is equal to 6 over x squared minus 9 equals 6 over x squared minus 9 minus 1 over x negative 3 minus 1 over x negative 3. So x over x plus 3 is equal to 6 over x squared negative 9 negative 1 over x negative 3. Gavin, first thing we should do here.
Group or factor.
All the polynomial denominators. So here,
Group.
here,
Factor. X positive 3, x negative 3. And then group.
all right, so what's the LCD going to be here, Noah?
X negative 3 is positive 3.
Now, I will throw this thought out there, class. The lazy side of me, watch, doesn't want to put parentheses and write x negative 3, x positive 3. Parentheses, x negative 3, x positive 3. Parentheses, x negative 3, x positive 3. I don't want to do that. So what I'm going to do is I'm just going to look up here. What would cancel here, class?
X positive.
X positive 3. I'm not going to cross it out up here. I'm just going to cross it out down here. What would be left up here, Maddie? Just the x negative 3. That's all I'm going to write. Class, what would cancel here?
All of it.
All of it. So there's nothing to write up here, correct? Class, what would cancel here?
X negative 3.
So what would I write up here?
X positive 3.
Do we see how, especially when it gets a really nasty, involved LCD like this, we can take a little bit of a shortcut? Big fan of shortcuts. So, Maddie, back to you. What's my equation now? Negative 3. This subtraction has to be distributed to both to get a negative x and a negative 3. And guess what we just created, class? Another quadratic. By the way, before we go any further, it wouldn't hurt to go ahead before we even solve it and say there are two things we cannot get for our answer. X is not allowed to be 3 or negative 3. It just can't be one of them. So the easy part for me is if I get one of those answers, I'm just going to cross it off real quick. But let's go ahead and solve here. It's a quadratic. We need to set it equal to 0. Which side should I make the 0, Noah? The left side should be the 0?
No, right.
What, the right side should be the 0?
No.
I got him all confused, bless him. We're going to make the right side the 0, Noah. Why? Because in a quadratic, you don't want x squared to be, class, negative. You do not want your x squared to be negative. You need it to be positive. And if I made this the 0, the x squared would move and become negative, right? So we want to leave the x squared where it is. That means the x needs to move over here, class, as a positive x, so that Noah, I now have a
Negative 2.
and then these I can combine real quick, class. Positive 3, and then move that positive 3 over as a negative 3. Questions on that step? A lot of moving stuff around here. Questions on the movement? All right, now what? Back to Noah for some redemption.
You do the binomial things.
Factor?
Yes.
Yeah.
And
You'd think you'd know that word by now.
x and x. Negative and positive.
There's only one way to split up a 3.
3 and 2. Or 3 and 1.
I'm about to say 3 times 1 would equal 3. Should it be 3 and 1 or 1 and 3?
3.
3 and 1. All right, so when I set each of these to 0, what do I get for my two answers?
X equals 3 negative
Thoughts on my answers, class?
Cross out the 3.
I already said it couldn't be 3. It's impossible. That's extraneous. I should probably still check the -1 just to make sure, because just because it's not one of these doesn't mean it actually works. Let's check real quick. If I plug that -1 in here, that gives me, of course, -1. -1 plus 3, 2. All right, then 6 over, and it says x squared minus 9. What is -1 squared?
1.
Positive 1 minus 9.
8, -8.
And then here I've got a -1 over, and then it's a -1, -3. Well, -1, -3, -4. 2 negatives in a fraction?
Cancel.
And I can reduce this down. Instead of 6/8, I could say
3/4.
-3/4, positive 1/4. What is -3/4, positive 1/4?
4/4.
-2/4. Signs are different, subtract each sign of the greater. And -2/4 would be -1/2. Yes, the -1 checks. Most of the time, if it's not an excluded value, it will check, but not always. It'd be good to make sure we're checking there. Do we understand how to check? Do you see what we did there? Just plugging the numbers in where the x's were. We're starting to feel like we're understanding this. One more problem that I want to work with you here. Write this one down if you would. X -5 over x positive 4 is equal to x -1 over x -4. Technically, you could multiply everything by the LCD here. Nothing wrong with that at all. But there's a quicker way. Because this is one fraction equal to one fraction. And if you have a single fraction equal to a single fraction, we call that a proportion. Write that in your notes. A single fraction equal to a single fraction is a proportion. A single fraction equal to a single fraction is a proportion. And how do I solve proportions, class? Come back to past years. Write this down, cross multiply. To solve a proportion, cross multiply. Do you remember that now that I've said it? Coming back to you from your junior high days. It just saves you a little bit of time of writing. Because frankly, if you multiply by x plus 4, x minus 4, which is the LCD, you put the x minus 4 over here, you put the x plus 4 over here. Well, I save my time writing that by just saying, okay, the x plus 4 and the x minus 1 are going to get multiplied. And the x minus 5, x minus 4 are going to get multiplied. And we're going to say that the product of the means equals the product of the extremes. Does that sound familiar to you? All coming back from your 8th grade years. So right here, let's do this FOIL first. First, outer, inner, last. What do we get here, Gavin? You're foiling. Two binomials, right? X plus 4, x minus 1, so multiply your first.
X squared.
Your outer, inner.
3. Negative. Positive 3.
Positive 3x. And then your last.
Negative 4.
Negative 4. All right, Brecken. Now we're going to FOIL these two binomials. First, outer, inner, last. Good, positive 20. And lo and behold, we have a quadratic, don't we? Or do we? Really, class, what's going to happen here? It's been a while since we could do that, right? Just cross out those x squares, they match. Which x is the little one, class?
3.
The negative. Now let's move it over as a, to get.
12x.
And at the same time, let's send the negative 4 over as a positive to get 24. And my answer, x equals 2. There were only 2 excluded values, negative 4 and positive 4. I didn't get either one of those. There's our answer. In your textbooks, I want you to do page 441 now. Page 441, number 1 and number 7. Page 441, number 1 and number 7. Check your answers. Yes, they really should have been this easy. You cross multiply the 3 times the x to get 3x, the 4 times the 7 to get 28. You divide by 3 to get x equals 28 thirds. How many have that on the first one? Questions number 1. Number 7. Cross multiply the 8 times x to get 8x. Cross multiply the 3 times the quantity 2x plus 12 to get 6x plus 36. Move over the 6x as negative, get 2x equals 36. X equals 18. How many have that answer for number 7? Questions on solving proportions. All right, should have been pretty straightforward for you. We'll take a look at more of those next time. Homework for this evening, though, is to do page 438. Page 438, review 1 through 23 odd, page 438, review 1 through 23 odd, except, giving you 3 problems you get to skip. You get to skip number 7, number 19, and number 21. So we're going to skip those 3. So it's 1 through 23 odd, but we're going to skip 3 of them. 7, 19, and 21 we will skip. All right, we'll take a look at that tomorrow. We'll also take a look at more of these rational equations in our next lesson. Have a wonderful rest of your day.